Okay, so this hangout on air is live.
Sweet. And can we invite other people?
I think so.
Whoever watches this in the future, just realize how cool we are.
Yeah. Yeah, that window in a window is a little wacky. All right, let's see here.
Ah, there it is. There's a button that says invite more people.
So we've got this. Let's see if that looks okay.
Can you, I don't, it doesn't look like it's letting me do anything. Try to invite Rob Giesberg.
Oh, it's really? Okay. Let's see.
Because I click it and it like
Invite.
doesn't do anything.
This is the intro.
That is nuts.
You know, you might have to go back to plus. Let's see. Let me go back. Okay, I'm on the details page. Invite more. Okay, who is it?
Actually, I can do it. I think
Okay.
I got it.
Yeah, there's like a live event page at this URL if you're seeing
Oh,
my.
nope, that was wrong.
No?
What URL? Post in the chat.
Yeah, yeah. Is it showing you my video?
I see your desktop.
Okay. Yeah, it's showing that my camera's on, but I'm not seeing my video. Maybe it can't do both.
Dad, I think we need your phone to start another one and it won't
Okay,
start.
go ahead.
Capture. Oh, I see. Maybe I got this. Could be because my video is being stolen by another window. Before we connected, I was trying to get this WebRTC live streaming video going so I could watch my. Yeah, here it is. So I
Oh,
could
sweet.
watch my CNC device in the ChiliPeppr view.
Nice.
So I'm gonna. That's looking pretty easy to do. So it'd be kind of sweet. I've got like a USB microscope hooked up to it as well.
Yeah, like you can see like this is the machine that I've got hooked up to it right now.
Oh, cool. Now, whose 3D printer is that?
It's a CNC machine. It's other mills.
Oh, yeah. That's the one that's got the tiny G embedded in it, right?
Yeah, yeah, yeah. I use that because they just had like all of the limit switches and whatnot already put in there.
Nice. Well, so they may actually appreciate this ChiliPeppr project.
Yeah, so the app that they write only works with Mac.
Yeah, which that's the thing. Like, why are people doing desktop apps still? Unless they didn't think the browser could handle this. And I'm
I think
seeing
the
that the
browser
browser
is
almost
something
does a
new.
better job than a desktop app.
The only thing I'm like really curious about is these faster machines. I mean, this is pretty slow right here. This guy. I mean, it's great for what it does, but for like even like the Shape Oko, I mean, I'm running at like what did it? Not the Shape Oko. Some of these like the 3D printer that I made. Uh, I can get it going at like 55,000 millimeters a second or a minute,
Okay. All right, that's pretty
and that's
huge.
really fast.
Well,
So
so you're right. You're saying it's going to starve the planner buffer.
it could. I don't know. I'm curious to
Yeah,
see.
but you know what you could do? This is like the perfect thing for this video on how to extend, because what you could do is you could be sending blocks of like 40 lines at a time or something
Hmm.
instead of what I'm doing, which is just piecemealing it. And I do add like 100 millisecond delay between each line. So
You
just
do?
configure it. Yeah,
Oh yeah, we got to
I
get rid of
do
that.
because the one thing about JavaScript, or at least the way I wrote it, is that it's event based and it's one thread. So you almost have to give it time to process other events. So by
See,
doing a
now
set
that's what I was
time
like.
zone,
I was going with, and then it's a little bit different than the architecture I came up with, but the way I was thinking about it, which I have not written, so take this with a grain of salt. But the way that I was going to do it was I was going to write it so that you would send a line, and you wouldn't send another until you got a response back.
Yep.
But at first you primed the pump with like 10 lines.
Okay. Yeah.
And then
Absolutely.
yeah, and then it's basically like you keep doing it. You send it, and then so you send like 10 lines, and then on your like response buffer, it knows to read back and parse your QRs, and then just manage how many QRs were sent, and that's how many goes back and re-enables the sender as well. So like one event triggers the other event, triggers the other event.
Yeah.
And I don't know if that's the same thing as similar what you're doing.
Well, so I really just start and send the first line blindly. I don't look for any response at all. I'm only looking for the planner buffer counter, that QV2 response. And then if
But you're never going to get like very full with that method, right?
every 100 milliseconds, you know what happens if it's a longer G-code move, you do get full.
Right.
And all I do is I wait for the tiny G widget to send me a pause signal.
Okay.
That's it. I'm just blind. I'm waiting for the pause signal. So I let the tiny G widget figure out when to tell me to pause, and then I just sort of yield all the sending until I get an unpause, and I go again. So the tiny G widget could be the one with the algorithm in it. The only thing is I may have to make the other widgets send faster.
Hey, let me get my notepad really quick. I want to take some notes.
Sure.
All right, Tom. Hey.
Okay, cool.
Hey.
Yeah, so, while we're talking about that, so this, this little pauser icon right here, this little timer
Show me.
in my screen.
Yeah, with the G code.
Yeah, this little indicator.
Move your mouse over what you're talking about.
Yeah, it's, I'm guessing maybe the screen share's delayed a bit. So I've got my mouse over the indicator right now on the axes widget, but really it's the one over here that really matters, over on the G-code sender widget.
Okay.
So if you look at the pub sub here, it's looking for this foreign publish. And foreign publish just means it's a signal that's owned by a different widget that this widget's just sort of watching. I'm sorry, foreign subscribe. So it subscribes to the planner pause and the planner resume signal.
So let's go back and just for the clarity for everyone else going to watch this. What is the difference between a foreign subscribe and a foreign publish? Is there a local subscribe, local publish?
Yeah, so the local publish and the local subscribe means that this widget, so this G-code sender widget, it's sort of the parent of some publish or subscribe signals, meaning it owns it controls them, it's the one that fires them off or subscribes. So you just sort of think about it as the parent. And the foreign publish and foreign subscribe, it's kind of like in a database model, you've got primary keys and then you've got like foreign keys where you're sort of referencing the key owned by a different table.
Right.
So the foreign subscribe in this example means It's just subscribing to this signal, planner pause. But that signal's not owned by the G-code sender widget. That signal's owned by
That's a global signal.
the tiny G widget over here. Well, all signals are global. Every
Right.
widget gets to see every other widget's pub subs. So pub subs are definitely global.
So I mean, like if you wanted to extend the 3D view to when it saw a publish pause, it could change the background to red or yellow.
Yes, you got it.
You
Exactly.
subscribe to pause and then implement your CSS or JavaScript.
You got it. And so that's why the tiny G widget, there's just a lot more documentation on what those two signals are, because it owns them. It's the owner of the publishing of that signal. And sometimes it can get confusing on whether you're publishing or subscribing, so it just sort of always helps to go back to look at this panel, to look at the docs. But on planner pause, this widget's publishing the signal when it determines the planner buffer is too full. And every other widget's got to react quickly to that. So,
so I think there's much tweaking that we can do right here, and that like little bit of code that we could probably implement differently.
There absolutely is, because if I if I go to fork this tiny G widget, and I'm up in JSFill here, you'll see that there's always usually a block of test code, by the way, at the top.
Right, and what is that method to run the test? Like, where do you wrap that at?
Got to end it in that comment, by the way. That's why it's always good, because the server, when it passes back to your final app, it looks for the end tag and the start tag, because it doesn't have a full code.
Where's the start at? Oh, the cheap
required test.
Required test. Okay.
Yeah. What it really means is that it'll run this code in JSFiddle, so you can mimic stuff. So see all these little set timeouts where I'm mimicking a publish signal? I'm like mimicking it as if some other method was publishing to me, like the serial port server. But I don't have it
was actually connected.
Yeah.
Cool.
And it is really nice, because then once you run, all that's gone, and it's sort of a pure, clean way to do it. And it's a lot like what we've all learned in the software development world about unit testing and JUnit. So
it's like almost integration testing, but not quite.
Right. In fact, if I go ahead and run this again, notice that you're going to get some updates over here. See the velocity updates and the state updates.
Shut down, run, yeah.
But it's just mimicking the signals that would be received from the serial port widget.
Right.
You probably should receive some planner buffer ones too to get a better test, but a lot of that pub sub documentation is actually in the code, and that's just manually done. If you write a new widget and you don't write your pub sub documentation, it's not going to show up automatically. You really got to put some work into it.
Right.
This planner pause at and planner resume at are the two most important variables for this widget. We could make the planner pause at a lower number, like 4, which just means
just from doing this for the past 2.5 years, I tell you that while that would probably help performance right there, the bigger problem to this whole architecture is the delay. Because that's what I started out doing in Java and TGFX.
Yeah.
And it works for the G code that you send at it. But the minute you send a G code that is just hell on wheels of the pseudo arcs, which is like horribly little tiny lines.
Yeah. You mean it's doing arcs as G1 commands?
Yeah. It's just trash at that point. So that's where like the delays kill you.
And so that's one of the things where I suppose what you could do is you could put that intelligence into the tiny G widget and then just make the other widgets send you more data, maybe quicker or bigger blocks, or you put that logic back over in the G code sender widget, and the tiny G one's just a little bit dumber, and that's more of an architectural decision.
Let's put it this way: you actually don't need to do anything. You can do a 0 delay. You're already opening the port with RTS on.
Yeah.
Excuse me.
Yeah,
so,
you noticed that, huh?
What's that?
You noticed that.
Yeah.
Actually, I don't think I was able to connect to the tiny G without that on. Or no, I wasn't able to connect without DTR on.
That's odd. RTS, you actually have to send it something, and then it will actually start talking to you again. It's very odd. Actually, it's the way it's implemented, but I, I'm
That's
sorry,
really
my kids are
weird.
in the background and I hear them. Like, as long as there's no blood, I think we're okay back here. So,
Yeah, I'm
uh,
just, so notice this this nitty gritty stuff coming back from the serial port server. It is saying RTS is on and DTR on is false.
uh,
So,
so that's interesting. Let me see if I can't pull up. No, I'm totally
but
unfamiliar.
I found if I had RTS not on, I wouldn't get any communication with the Tiny G. So I had to go take the
I don't
serial.
exactly understand why that would be. On the G2 stuff, on the Arduino, and our specific board that we've been manufacturing.
Yeah.
You have to toggle the RTS, and then it'll talk. It's actually kind of funny because a lot of people, funny is like it's a support kind of craziness, but they'll be like, it won't talk to us, and we're like, oh, toggle that, and then it will. So
Yeah, maybe that's all it was, is that I don't have a way to toggle it in the Golang code yet for that server, so I'm just leaving it on. And
So, but that's what I'm saying. Is in theory, as long as like the Golang serial port flow control for CTS RTS is working correctly,
yeah,
you should be able to send a huge, huge, huge file at it.
it
And
might be worth experimenting with it then, because it's really just yielding to the operating system at that point.
yeah, it is. Give me 1 second, John. 1 second.
So I gotta believe it is, because like on Windows, the way that code was
Hey,
written.
John, 1 second, real quick. My daughter's walking in.
Yep.
Hey, I'm back, John.
Okay, yeah, I'm back.
Hey, cool. So yeah, you're absolutely right. You're at the operating system's mercy, which is kind of cool and kind of terrible. Kind of cool because you're not going to overflow the buffer. Kind of terrible because you lose the ability to pause and resume. So
Right.
it would be interesting to let's pull that 100 out and just say send the file. Don't
Yeah.
do anything. We'll lose the ability to pause, but that's what the QRs are supposed to be for.
Right.
So basically, will never be any more than whatever our high water buffer is, like 18 moves into the planner or so before we're going to do a pause,
Yeah.
which is emergency stop and all that stuff. There is no such thing. It's actually just stop. Emergency stop is always just to hit the power to the motors, right?
Right. Right. Which we've all done.
Right, right, right. So
Well,
just as long as
I
that's
feel like more of that maybe is the design decision you guys have to make for the Tiny G itself. I'm just going to kind of work with whatever you make available, and I do think the planner buffer is pretty good, and I feel like you could do a little bit more intelligence on the G code sender. Look, I got to do something anyway, or maybe somebody else will, where they analyze each line of code and see how far the movement is to estimate the duration of the job, and you really got to do an estimate per line.
well, it's
And
not even that. It's about velocities too.
well, but that would be part of the estimation, right? If you're doing a 100 millimeter move at a 10,000 millimeter move rate, it's going to go really quick versus a
No. So
30
yeah,
millimeter
but
rate.
you're still getting drift on that, because it's a lot harder than you actually think, because you have to actually take into account to your maximum jerk and your deceleration acceleration settings
Yeah,
because
but I
that's
mean,
grow.
you could estimate that part.
You could, but I'm just saying it's not gonna be exact. And if you have a 2-hour job, you're gonna be off by quite a bit at the end.
You will, but I do think it could be enough to make you decide in the code to send a block of 5 lines or 10 lines instead of just 1 line.
How would
And
that influence how many you sent?
so I'm only sending one at a time with that 100 millisecond delay. But if
Yeah,
I
but why do we care at all about like the size or whatever? Why wouldn't we just say about the planner?
I think it's still in tandem, but if I run this job right now, which I could do, you'll notice here. I'm gonna go ahead and run it. So notice planner buffer's down at 11. Are you seeing that?
I am, yeah.
Okay, these moves, when I'm in G2, G3 moves, those are chewing up a lot of the planner buffer from 1 line of G code being sent. So I'm actually okay on those. When I have these long, straight G1 moves, I could feed more data into the planner buffer to just queue it up. It's funny, this bar has an animation attached to it, and the animation is not running because there's too much process going because of this Google Hangout.
Mm.
Let me turn off this console just to save some processing. But when I get over into this little actual ChiliPeppr, I have a ton of those pseudo moves. And I end up with the planner buffer lingering around 26. I'm not sending enough to it.
That's because your 100 milliseconds is delaying
It's
you.
too slow then, right? So that's
Right.
all.
So that's what I was trying to say. Is like that's going to get you.
But I could send 5 blocks of data when I'm in that section of G code. Whereas this section, I think I'm fine. I mean, it works pretty well.
So, I guess maybe you don't agree, and this is why we're having this talk here. But anytime we're doing anything with delay, we've already lost because delay is kind of a band-aid in my opinion. There's no real like. That's kind of the way I looked at it when I started doing this. Delay might work for this file, but it won't work for that file. And if that's the solution, then we're already losing. You know what I mean?
Yeah, okay, so I could make that delay be way less, right? I could make it there be no delay.
Any delay.
Or at least I could give it a 1 millisecond delay.
Well, I mean, that's fine too.
The delay I picked is still getting me a pretty good ratio on the planner buffer. I mean, look, I'm at 100 millisecond delay, and I'm down at the planner buffer being at 1.
Yeah, but run Braid against this and see what happens.
Well, here, let's do that.
Also, one of the just a little comments I'd throw in here is I've taken notes about like what I would what we not you what we need to like work on would be to be able to tell when you're actually connected versus pseudo connected. You know what I mean? Because your test serial port console runs a lot of the time, and you see stuff happening, but I think the average user doesn't know it's not connected. He says send line, and it just doesn't. There needs to be a better, clear indicator of it actually works.
You know what? It does throw up an error though if you just on that note. So if I disconnect.
Right, but now click the 3D viewer and click play.
It's I mean, of course it's playing the comments, but there it is. We couldn't find the serial port you're trying to write to.
Maybe right, but I'm still writing a whole bunch of lines, and I'm like, oh, it should be working. What's going on here?
Yeah.
It's just a little confusing. I know that you get it, and I know that I get it now. I'm just telling you, like, what I got confused with.
And the other problem is if you switch to 3D viewer, you're just running a simulation.
Right. That's the other one, and so that's the other. Because at first I was just using that one because I didn't know what I was doing. And then I was like, oh, why isn't it moving? I don't get it. This is weird, you know.
Yeah. So, yeah, that probably does need to be a little bit more obvious, and maybe an indicator here that some reading and writing's going on, like the way your phone shows you up down data. I don't know.
Yeah, like it just, you know, I mean, it's almost to the point. I don't know how to fix it. I'm just like a complaining session, but it's almost like the 3D viewer has a play button next to it and a stop and a pause, and then there's a G code stop and pause, and that's confusing maybe a little bit.
Yeah, no, I thought that was confusing early on too.
Yeah, I don't have an answer for you, but I just tell you that is.
It's almost like this should say simulator right here instead of 3D viewer.
Yeah.
All this is a simulator.
or simulation, or yeah, something
But
like
then
that.
again, it's not a simulator when it's getting feedback data from the tiny G on the XYZ. It's just showing you a real view. So
But you're not but hmm, maybe you actually break out that play button and then stop and the pause and the 1x thing into another widget, and you make a simulator widget.
yeah,
Yeah, that would
yeah.
actually.
And I think that that is good feedback once other people start using it, because when you're putting this together as a little weekend project, you just kind of whip up some JS fiddles and see if it works, and then you
No,
kind
dude, again, I'm
of
not complaining at all.
it was definitely a lot of on the fly design.
Yeah, I'm
I
just
think
telling
it
you that
actually
I
came
got
out pretty
confused with a
nice.
couple of things.
If when I compare it to the Mach 3 interface, I feel like this is just light years beyond the way that interface tried to lay everything out. Doing
Right.
Lit is a lot of decision making.
It is. It is. So, anyways, getting back to braid, I just want to
Yeah,
throw that
and
in here
what's
because
the smallest braid that actually could fit on my Shape Oko layout? Do you have like a 150 millimeter one?
I think
I think
those are
this
all speed
100.
size. Those are speed, not size.
Uh,
They're all the same size.
are they? Why is it 300? Oh, it's 300 millimeter per is the feed rate.
That's 300 millimeters a minute.
I got ya.
So I usually do an 800, and that's a pretty good test. I mean, obviously the Shape Oko is going to be able to haul about like the 2000 okay.
Well, what's funny is I could just do the feed rate adjust on whatever of them then, right? So if
Oh,
I
you have a little feed rate override on there.
yeah, so see how it goes blue when it's adjusting the feed rate.
Show that again.
See when you adjust the feed rate, it changes the F's to blue.
Are you at 1.5, the multiplier? Is that what it's
Yeah.
doing?
Yeah, and
Ah,
so see this one, it was at 800, now it's at 1200. When
yeah.
you
We should.
mouse over
I'm
it,
gonna make a note on that real quick because that feed rate X. I'll do feed rate override.
yeah, and then it's just easier to, and you can do that on the fly as you're sending the job.
So anything sequential or after that that hasn't been sent is going to be multiplied differently.
That's correct. It's definitely not a like sending some feed rate adjust right to the tiny G on the
Right.
fly. That
Yeah.
would be cool, but
Which actually like makes it even harder to do time time estimation once you change that.
yeah, exactly.
Yeah. Okay. Well, that's cool. So yeah, give this guy a shot and see what kind of actual movement we have on your Shape
Okay,
Oko.
now I'm a little worried. Let me pull up the video feed to my um, because I'm not in the same room as the CNC machine, which is why I want this video feed.
No, I know.
So
What is WebRTC?
yeah, so WebRTC is just a really cool in the browser video stream. I don't know if it's still in my.
Did you take a look at Octoprint?
No.
Yeah, take a look at Octoprint. It should give you some good ideas. It's basically what you're doing with 3D printers, though.
Okay. Let me. I'm gonna actually go into the room that's got my CNC because I don't. I'm worried that this is larger than the work bed.
It is not. But the problem is, do you see how your zero's in the top dead center?
Yeah.
So you actually would have to center it and then do it. But it's
Yeah.
not
I
bigger.
think my zero's pretty centered right now, but.
Well, I know, but look at the machine. Look at the way that the ChiliPeppr showing it.
Yeah.
So you
No.
have to have zero is in the very center of your machine.
Yeah, which is actually it's roughly where I'm at because if you
Oh, okay.
go to this. By the way, this was added yesterday. The recent files. If you go to the way this one was set up, notice it's pretty much the zeros at the center of the machine.
Where's the recent files? Where, maybe I
The
can't see.
recent files is up where the drag drop icon is now, and now you can kind of see the recent
Oh,
files that
cool.
you brought in. It doesn't hold a lot. The browser only gives you like 5 meg of local storage.
Oh, that's local. That's local. Oh, not very local storage. I'm sorry. That's a. Help me out here. The HTML5 storage.
Exactly.
Yeah.
Okay, so I'm going to go ahead and run this now. Let's see what happens. Oh, I'm not connected.
Right. So almost like when you do that, I think we should actually throw exception and like stop.
Yeah. Well, It could, but if you're running a simulation, you don't want to. You're right. There's a couple better ways to handle that. So
Well, I'm just trying to take notes about like that where the confusion's at.
yeah. All right. Here we go. Okay, so it's starting to move. So I think watching the planner buffer is going to be the most beneficial here. And yeah, I'm only up around 20. You know, I'm starving it right now.
Right, right. Being up by 25 is actually a bad thing.
Right. Because I'm not
I'm just saying that for the audience. That's all.
Yeah, and I don't know if you can hear it, but it's definitely getting starved. So this is where I feel like if you're estimating how tiny these moves are, you could say, okay, I'm going to send faster or I'm going to send bigger blocks. So it's definitely starving it.
And so if we saw your video, do you have a video of your guy running right now?
Can you switch to that? I could probably pull one up. Let me, instead of using WebRTC to do it. Actually, I could do WebRTC.
If it's easy, cool. If not, don't worry about it. I was going to say that like what you're going to be seeing right now for everyone else is going to be like this thing's going to be stuttering kind of thing. And
yeah, it is definitely stuttering.
Which basically means that, just for everyone else, your acceleration and deceleration profiles and your constant jerk, you're not getting any of that added benefit from TinyG.
Yeah, totally. Zero benefit.
So your cuts are going to be really kind of, I'm almost to the point of being rigid.
Yeah. Okay, so here's, actually I want to come with my, because I want to get this out of the way. So are you seeing that?
Yeah, I'm seeing it.
How do you...
It's moving at like 2 frames a second.
Yeah.
That's you now.
I'm trying to figure out how to turn off this video, because it's in the way.
I mean, I see it just fine right there. I mean, I see you too, but...
Yeah, okay, well, whatever. So it is, yeah, it's definitely getting started. And I think I'm getting feedback here now.
Yeah, in the other room maybe, or the other device you have on. Yeah, so anyways.
Yeah, I think we both kind of, I recognize that part, and I think the braid is a really good test.
This killed us, man, at the beginning.
Yeah.
Like, this is the whole reason that, you know, we had to go back to the drawing board on, why can't we just do what 3D printers are doing? Current ramps and stuff like that, and why can't we just count bytes and kind of, it's because we're sending so much faster and planning and moving faster.
Yeah. But you know, if I take, let's just do a quick experiment, because this kind of helps show how easy it is to modify. Let's go, I'm going to go fork this, and because I'm the owner of it, I don't actually have to fork it. I just use that menu to get over to JS Fiddle, to the widget, and then I'm going to go down to the section. I don't know if I made this a global variable, but let's see. There is a delay, and if there's not, I'm going to make it a global variable. So there's a method called playNext. And that's what's got the delay built into it. There's a lot of code in this one. Okay, so time start, time end. Now play current line.
Actually, just invited a lot of our circles to join us if anyone wants to jump in and see TinyG and UI with a browser.
Okay, so it's definitely going to be the on play next, as long as when I find it. One of the downsides of JS Fiddle is there is no easy way to do a find.
I know, it's terrible.
That is the worst part. But there's so many benefits to doing it this way.
Can you click in the frame and hit Control A?
What, in here?
Yeah, in one frame.
You can.
Yeah. So what I would do is, actually, this is how I did it. I didn't know if Windows would do the same, but I'd copy it all, throw it into Sublime Text, and then hit Control A.
You could absolutely do it that way.
Yeah, it's not as cool, but
Yeah, I gotta
On the
get.
functions that are just huge, it's kind of like the only way.
Yeah, and this one is definitely huge. I'm sure some programmers out there would make fun of how massive this object is. So it's funny because there's different sections. Here we go. We're almost there. That's the infinite scroll. Jeez. I wrote this code, and even I'm a little bit. Here it is. Okay, I actually have a 200 millisecond delay. So what I'm going to do is I'm going to move this out to be dot. For now, we'll just call it delay. We'll do. And then I'm going to go back to the top. This could even be put in.
Is that delay per line? Is that a variable?
It's going to be right now, yeah. I'm going to make it a global. So the globals are all right here. I shouldn't call it a global either, though, because this is inside an object. It's really just a property.
Yeah.
But we'll make it now be 50 milliseconds.
Okay.
So second delay between the send of serial port. All right, so I'm gonna now
yeah, let's see what Braid does with the same file on that one.
Yeah, no, I'm gonna open the JavaScript console just to make sure I get no errors when I rerun, and then I'm going to run the job to make sure it gets into that section of code, and it's running at the 50 millisecond right now. Just for comparison,
What do you mean? What are you gonna run?
I'm gonna bump it to 5,000. So all I'm doing is I'm running it inside JS Fiddle.
Okay.
And it's not sending anywhere because I don't have any other widgets loaded, but you can see the debug output. So look how slowly it's going to wait. I put a 5-second delay.
5-second delay. Yeah, no. I was just saying when you said run, I want to make sure that we were clear on. It's not actually talking to anything.
No.
This is a unit test.
Right. This is just, which is why it's so cool to do these as standalone. Yeah. You can kind of debug it, make sure everything's looking pretty, and then once you're happy, you say update, and you got to do set as base because it creates these version numbers. Notice I'm on version 78 of this widget. It's been a lot of updates.
And then you need to set yours as base.
So now I set it as base, and now I'm going to go back over to the hardware fiddle. I'm just going to reload.
The set as base, by the way, was a little blue icon up at the top. I know that you can kind of zip by it, but there's another button on the top bar.
Yeah, the update working base.
Yeah, but it was right there in that blue bar. All right, cool. And since your widget is the official widget that what this Tiny G ChiliPeppr is pointing at, it's going to update automatically. So there's no need to, change.
Correct. And what you would do, and I don't know if you noticed, but I did update the your wiki.
Okay, cool. So tonight I'm actually doing more on that.
Because if you want to have live updates like what I just had, you just follow these steps. So I'm on the wiki right now. I added the video.
Oh, sweet.
It's a 20-minute video, so there's a lot to it. But if you follow these 3 steps, you're good to go with your own version, and then you can just make live updates.
Yeah, Alden is going to talk to some of the Shapeoko guys next week.
Yeah.
And he's using our wiki, this page right here, as a test thing, because Alden is a brilliant individual for like low embedded stuff, but like this kind of web stuff is not his forte. So he's going to use us as a guinea pig.
Cool.
Or our documentation, and he'll be the guinea pig to like going through and getting this working.
All right, let's try and run this with that 50 millisecond and just see if it helps us.
All right, so you're already seeing a difference right there because you're at 24.
No, it was doing that initially.
Oh, was it? I didn't see that.
I'm a little better. Remember, before I was around.
But watch that right there. Watch the edges, and you're gonna get killed.
Yep. I'm only maybe an average of 3 planner buffer items better. Although I gotta say, I'm way less starved. I got way smoother movement.
But remember what I said though. Is this is like a
Now it's getting starved.
Yeah, that little right there. This is just like it works great for this file right here. Now go send the one that is 18 millimeters a second, 18,000 millimeters a second.
Yeah.
Or minute, I'm
Okay.
sorry. Yeah.
All right.
But, so do the same thing, stop this job, and set it at 0.
Set it at what?
0.
0?
Yeah.
The feed rate?
Yep.
It won't move at all.
No. The delay.
Oh, the delay.
Yeah.
Sure. Okay.
So as long as flow control is like accurately working, it'll work perfect.
Well, even at 0, it is still gonna loop. I gotta set it. I gotta give it some time to yield. If I do 0, there's not going to be any time in the single thread of the JavaScript to process pause commands.
I know. Just do it. Because basically what we're showing you is flow and control in the operating system on the your Windows machine or your BeagleBone or whatever you're doing.
You gotta understand. But what I'm at the limits of JavaScript now. I can't. I'm still in a JavaScript environment. I'm gonna set it to 1 millisecond.
Oh, you can do 1. Yeah, that's fine.
Because I just know how JavaScript runs and how this app. It's just in one thread.
Right, but go to your but show us the output of your machine though.
Well, here, really quick. It's on 1 millisecond. Watch what it does. I got 572 lines. And if it were able to run as quickly as it could, it takes the durations right here. That's 8 seconds to send them all.
Right.
So that's pretty fast.
Right.
Let's reload.
And so your operating system is going to be buffering all that. So you're going to send a crap load of stuff right off the bat. In 8 seconds, you're going to send this whole file, or whatever it is. Not the file, but what you did.
Right.
And then you're just going to be parsing responses.
All right, let's go. There, I quickly get down to 3 in the planner buffer. And the thing is, I send the pause at 12, which means it's working better.
Yep.
But I'm still getting lag.
What's lagging?
I'm still getting the shape OCO, the tiny G, feeling like it's started, even though the planner buffer is showing me that it's loaded.
I bet you it's at 1.
And that's the problem, is my feedback loop too slow. But notice I'm not really up in the blue of the planner buffer at all.
Yeah. Yeah, this is exactly what I would expect to be happening.
Are you hearing it?
That's so here's a do you have CoolTerm on this box?
No.
You should get it because and this comes from experience, but I actually troubleshot this very similar problem for weeks trying to figure out why my Java wasn't sending right and it was delays and whatever. And it turned out that it actually wasn't Java at all. It was my settings on my board. My maximum acceleration, my maximum jerk, all of that was set up.
Right.
Yeah, so you very well could be doing exactly what it's supposed to be doing.
But you're right, my settings, I have not tweaked any of those jerk settings or any of that stuff.
Yeah, so you very well could be. And so here's the best way to test am I stupid? And I use this quite frequently. I connect CoolTerm, I set to RTS on, and then I click send file. And if it jacks up the same way that it's jacking up in your code, that means your code is fine and the other code is fine. And it's something else. It's settings.
Yeah.
So it very, very, very well could be that like it's actually working just fine.
Yeah.
Yeah. It's kind of ridiculous.
Well, Riley, you can fork any of this and play with it.
I will. I absolutely will. I just wanted to.
I think your experience too on all the other stuff you've done is going to be invaluable to figure out the best formula. I do think because we're in this browser JavaScript environment, we've got some other stuff to deal with, but.
Yeah, I'm still, like, I know we discussed it briefly. I still don't think that sending directly from the browser is the best way to go about it.
Yeah. Sure.
I almost think, I mean, I really like the idea of uploading the whole file to the Go server. And then once the Go server gets there, it just listens for certain things. So the Go server is actually the guy that that monitors the. I mean, in my opinion, this is how we should do it. Let me know if there's.
Yeah, no, I like where you're going with it. You just got to put a lot more complicated code in the Go server.
You basically do the QR tracking inside of Go.
Yeah.
Everything else is fine. You leave it alone and do whatever you want to do. But you do every. So at that point, it's agnostic to like whatever. It's like I'll send it, and the Go server is going to make sure that the QRs are getting parsed, and it's never getting outside of that. And you've got your multi-threaded environment right in there.
Yep.
I actually haven't looked very much into the Go code at all.
It's a lot of threading. So Go has something called channels, which are really just threads, and they're super easy to use. And it's native code, so it's fast. It really is a great place to do it. And then, yeah, you're just sending JSON updates back to the browser, and the way less work. I think it's cool. You could
and then
just upload the whole file to the serial port server.
Yep.
And it either puts it in memory or it puts it to disk. It probably could just put it to memory, and then it's just giving you updates.
You could do either one, or you could just say, I mean, if you have like a 16 meg 3D printed file, it's actually not that uncommon, right? So you throw up. I mean, do you wait till you upload all 1600 or 16 million bytes, or do we just send up what? That's just all polish, spit and polish, whatever. But no. I think and you can probably do it mostly in memory. But I mean, if you're doing it on these BeagleBone Black devices and stuff like that, you might want to put it to disk. Who knows?
Yeah.
But anyways, my point being is, if we uploaded that to disk or memory into the server itself,
yeah,
we could actually do all of the QR parsing code there, and then it would send us responses and listen for input. So maybe we have a way to do interrupts to where we send pause, and it gets jumped into the buffer that's 20 moves full all the time. So
yeah.
I don't know.
Yeah, so I think that, let me jump over to the source code. I think with this part being open source as well, then going in and changing, the main.go file.
Yeah, I'll take a look at that and see if I can
to, it is a web server as well, which is at the root folder, and then that's the WebSocket. So you could add some RESTful calls to the web server itself to do things like file upload and sort of queue things up. You could also do that through the WebSocket, but there's some easy ways to do that. Notice that even the home page is embedded. I don't even know if you've ever gone to the home page of that, but it just pulls up a really quick, simple console. So you could do a lot of it. And this is why I used Go, because they have really standard modern stuff in what's otherwise a C environment. This is like C code.
Yeah.
But you see that go hrun, go shrun? All that means is spawn a thread for the main hub, spawn a thread for the serial port hub, and then all those hubs can talk to each other through channels.
Right.
So Go has just done a brilliant job. So you got to learn it, but
yeah, that's the only other problem. Where's your the response parsing code?
If you go into the hub, see all these channels? Those are really
channels or like threads. Yeah.
Although really what they are is they are commands you can send from a thread to another thread. They're called channels. So this one I've got register unrest. This really is handling the WebSocket connections. I mean, you could connect as many parallel WebSockets as you want to one serial port server.
Right.
But the check command is when you send things like open or close, and it dishes it off to the handler routines after it does a little bit of error checking. So
like in the serial Java stuff that I've been working on, you have like the serial event clause where it just fires an interrupt when you get bytes in the buffer. Is that somewhat similar here?
Yeah, I'll show you that part. When it gets, so serial.go is where that happens, and this is its own thread. And when it opens up, see how there's a write
What is a for select case thing?
Yeah, so that's a new thing in Go.
Yeah, I saw that. I was like, what is
And what
that?
it does is, you know how I was talking about those channels?
Yeah.
So right here, I have these channels called write and register and unregister. And what it does when it gets to the run method, it will block. This is almost like an infinite loop, but it's done really well where
So you're not spinning out of control?
you actually Go takes care of the blocking for you, but you'll receive events in the run method, and it will then analyze whether it was a register event or an unregister event and give you the value of the variable passed in so you can then do other stuff. So this is really like your event handling loop
Right.
to talk across threads using this channel. And so this little arrow is really saying, this is a channel signal coming in. It is a little bit like a pub sub, but it's a little bit more structured and done the way Go's doing it.
Right.
So,
And then your serial event?
yeah, I'm in the wrong file, I think. Let me go.
I'm just doing, since we're recording this, I thought we'd just grab
Yeah.
like.
I think that's under serial port. Okay, so what I do is I open a reader and I open a writer, but the writer is not, yeah, here's the writer. So obviously that's all you're doing, reading and writing. But I'll show you what happens on the reader. So once it's open to the serial port, the reader is the thread that just sits there staring at the serial port, and it gets its data in this for loop. That's an infinite for loop, but it's going to pause at the read statement. It blocks here. But blocking is fine because it's in its own thread. You want it to block. It makes your code way easier to write. And that was important because I used somebody else's serial port code, and I had to get one that had blocking turned on, not non-blocking, because I would rather use Go's channels and threads to solve what people otherwise use for non-blocking. So it's really simple. If the number of bytes I get are greater than 0, pull the data into a data byte array, and then I'm creating my JSON structure, which is the port name and the data. That's that. I'm going to show you. Oh, I'm in the same window. That's when you've got this console open. Let me reconnect. And I've got the console open. And we'll send some quick data and then turn it off. But see all this PD stuff?
Yeah.
That's the port and the data.
I don't think I see that on mine. Do you have to like enable that?
You got to open this console to see the low-level JSON communication.
Oh, okay.
You're over here. You're seeing the converted form. So notice this: the data is sent back as quickly as the Golang receives it. So you got lines really split across. See, that's the new line right there. So that's one line is being sent really as like two WebSocket JSON strings. That gets a little bit bloated, which I don't like. So that could be an option too, is to ask it to send back full lines rather than piecemeal.
What's it doing? I don't understand. What do you mean?
When I'm back in this code over here that I was showing you, the moment it gets unblocked, which is really random, it depends on what the operating system's doing.
Right, like in Java, I'd have to. I don't. Do you have to do this? Just a quick question. In Java, like in the serial port, both libraries that I used, I have to check to see like if it didn't start in the middle of a JSON object or the end of a new line character or something like that. Like you have to basically parse out or build a string and then send the whole string down or object down.
You know what I do? I move that to a higher layer. I move that to the serial port widget gets the data as quickly as it can, and it buffers itself waiting for a new line, and then it throws off like a data receive line pub sub.
In the browser.
Other widgets can just consume data as a single line of data. So I moved it higher layer in the logic and in the architecture. So see this WS send and send? Send.
You have to like go slower because I think you're lagging, and then you start talking. There you go. I see this. I see that send. Yeah.
So send, WS send is low level, send is high level, meaning you will only get a send when it's a full line of serial port data. If you want to listen for lower level data, you can as well on this signal. But if you want to be lazy and just wait for full lines, listen on this. It's up to you. I would say all of the widgets right now only listen to the higher level one because I was too lazy to want to like reparse it, and why bother? Let this reparse it. But all I'm saying is I'm not having the serial port server parse per line because I wanted to write it in a generic way. And if somebody writes an Arduino app that doesn't want new lines and they just want to send one character in and get a character back,
Yeah.
this all will work correctly for them.
I guess, I mean, what we could do is, you know, just for optimizations, I understand your like global intent on this, but for optimizations, we could probably just fork a SPJS serial port JSON sender for TinyG, and then implement all of that stuff there.
Yeah, absolutely.
But I think you would actually gain some performance from that way. Sending full line JSON objects and parsing it in C, you know?
Yeah, you would. There would, because it's really chatty. I mean, if you added up the amount of bytes coming back and forth because of the JSON, it's probably inflating it by double or more, triple it maybe.
Right. We probably want to look at that. Hold on, let me see my notes.
I mean, obviously we're at a good start here, but yeah, this could get way fancier to squeeze out optimizations.
Yeah, I mean, yeah, I like your idea of like having the JSON serial port server just sitting there for any application. But I mean, if we want to like squeeze the most out of what we can do for like full on real time milling, we might have to make some kind of like break compatibility. You know what I mean? I don't mean to, but it might work better that way. Whereas like this probably wouldn't work very well on Arduino because you're not listening for JSON responses back.
Yeah, well, and you know that's why one of the initial inspirations to this was to do. I'm going to show it to you. It was to this inductance position sensor is another little weekend project I've been working on, and I've got it connected here. It's on this Arduino. And so it's got its own set of
JSON or no?
What's that?
It's sending JSON?
Yeah, I mean you can see the raw JSON, but no, it's just a text interface. So like if I say I for ID, I'm getting back the firmware ID off of the Texas Instruments chip through the Arduino, through the I2C bus. But if I turn this on and I go to channel 1 and I say F for frequency, I'm reading position frequency off of an inductor over and over, but I don't want to do this through new lines. It's going to be too much data. So I'm just going to keep, expecting 5 characters back each time. And so I just didn't want the serial port JSON server to not support scenarios like that, because what I'm going to do is I'm going to fork the TinyG space and be bound into the TinyG over a serial port and the Arduino, and I'm going to get a full closed loop system where I know the position of the CNC machine, but I didn't have to do anything through the TinyG to do it. I'm mashing up 2 streams of serial port data through JavaScript.
I guess the question then is how much of a improvement do you think we'd get if we did do the specific JSON object parsing on the Go server for TinyG specific applications? Do you think it's significant? I just had a kid moment too.
So, do I think it's significant? I left this super generic, but I feel like there's no reason to not go add more specific stuff to it.
Okay. Well, I mean, this is just another thing I'm just writing down, stuff that we can test, actually.
Yeah, I think, why not? I mean, it's all open source. Who cares, right? Let's just go for it. It is worth trying to keep the architecture somewhat separated so that it's useful for other projects. But
I mean, if you got like a crazy like 200% like performance increase, all right, we probably want to do it there, you know.
it's totally worth it. Yeah.
Yeah, yeah.
By the way, I don't know if you noticed some of the niceties, but if you want to repeat commands and stuff, it shows everything you've done.
Yep.
And that works in the, in this interface too. If you're trying to just,
I was actually thinking about looking at doing an ACE editor for the G code. Have you looked at ACE?
I've seen, ACE is being used a lot out there. I don't know.
I was just curious if you looked at it.
I think my server died. I am finding that.
Are you going over the network?
Yeah, I'm finding that there's some. Shoot. That there are some bugs in the serial port JSON server right now where if you open it up, the port, and you send a command too quickly, it'll crash. And I think it's just some of my cross-threading stuff.
Mm-hmm.
So that's going to need fixes. I think I just crashed my serial port JSON server.
On the bright side, I have got it working on the BeagleBone, and it works really well, so
good.
I'm really stoked about that.
Yeah, that is pretty awesome that it just worked without any real testing.
Yeah, no, there wasn't a lot to do. So, okay, if how do we handle the tiny g and delays and the QRs and whatnot? That we talked about uploading the file possibly.
Yeah, and I think what you could do if you want to play around with that is.
I'm just trying to recap, take notes.
Yeah, you could pull down the source code for the serial port JSON server and try and just go in there and muck with the idea of uploading the whole file. And then I would just figure out a standard WebSocket protocol to give feedback on which line of G code you're on. Or you can try and do it in a generic way and just call it a serial port command upload where you're uploading a list of serial port commands. Just because it's G code or whether it's custom commands somebody invented for their laser pulsar, and then it's just sending back which line it's working on.
Almost like you abstract the two because like you don't want to send you want to be able to send a G code file. I don't want to be able to send generic tiny G commands in.
Right.
Like it's almost like an abstract method of like send a G code file, and when I do that, it starts an upload, gives me a little UI, says it's uploading it, and it's ready to go, and then we can do all there. Because like you wouldn't want to be able to send. There's problems with a tiny G V7 and below, or V8 and below with like not problems but architectural problems. Like you can't send like 42 settings right in a row because we actually have
it freaks.
We have to disable the interrupts and then write to the EPROM. This is the X mega limitation. It's not our code.
Yeah.
And then bring it back up. And so that's the only time I've ever implemented delays is when you're doing a write a config string. Once you're doing that, I implement delays. I say wait, 100 milliseconds, and then send another one.
Yeah, and anytime you're writing code where you're putting artificial delays, you start to worry that it's a half-ass architecture. But sometimes it's just necessary because
you can't get around it.
I have artificial delays in here, and I'm not happy with it. Like when you connect to the serial port again, I artificially delay sending these setup commands to solve the port server crashing. So it is what it is, and of course these are just weekend projects, so you just got to get it to work, and it's working. I'm sending real jobs now, and I'm really happy. So
yeah. But I mean, this is the kind of like things that we document, and then we start saying, "Hey, we have a weekend. Let's figure out why it's crashing."
Yeah, absolutely.
Yeah. And so as long as we can document these and try to kind of keep going for it, but yeah. So I'll take a look at the C or the C Go code, whatever, to see if we can't upload those files. I think that you have a generic like prototype where you say like upload G code file, and then it says like you're going to upload it all. And I mean, maybe even make it optional. I don't know. Maybe we extend the G code sender widget to where we say like click the checkbox to make send this file directly, or like buffer it on the server, or maybe we just make them all buffered on the server. That way, like you don't have users breaking. Like my stuff runs like junk on your stuff,
Right.
Yeah.
So here's like one idea. Let's say add handler to upload file. Okay. And it might just be something like upload. And then you would change this to be a new method called upload handler. Probably should copy the home handler. Oops. I'm using light IDE here to edit the Golang. So see how simple the home handler is?
Yeah.
I'll just copy that, and we'll call it the upload handler. You're not going to want to execute a template. Instead, you're going to want to allow a file upload. The question is whether we use the true file upload method of HTTP, or we just expect a large post. I will say doing a post is way easier than a file upload.
What's your speed? Which one's faster? Post?
There's probably going to be the same speed. It's whether you just want to, posts are so much more common than file uploads.
But you're talking about actual REST standards, like put?
Yeah, like the RESTful interface.
Like put.
Yeah. And so this is now where I would say, okay, let's go steal somebody's code that they've got. So we'll do Golang, and then maybe like file upload.
Right.
And then you just got to go grab somebody's. Actually, I think there was a better one down here. Okay, so he's got a hello server. That's not bad. Form file. Read all. And then write file. So he's just writing it out. He made his be /upload, so did we. And then you're just doing this, file stuff. That's actually going to be a problem though, because this requires the user to click a browse button, and we don't want to do that. We need to do it programmatically. So I don't think it's going to work.
Hook the drag and drop?
Because once it's drag and dropped and you've rendered it into 3D viewer and all that, you just have it as a string. And if you're going to do a file upload later, like when they hit the play button, or even if you're going to do it asynchronously.
I think the minute you drag and drop it, it should just start assuming you're going to want to send this file and start sending it.
It could, but you can't really trigger this off a drag and drop either. Because of the security built into the browser, you cannot set the value of this file, I don't think. So this will take some playing. But
when you drag and drop it, you're populating. Sorry if I'm not grasping this very well. But you drag and drop it, it's automatically populated inside of the G-code widget.
Yeah, it is.
The content, right?
Yeah, but I'm just saying that input file upload.
Right, but I'm saying since you have these lines by lines, you would have to just do a bunch of posts. Or a large post?
A post can actually be, I think, an unlimited amount of data. These are, by the way, the local storage values, the last imported file or the recent.
Why can't we throw it through WebSockets?
Yeah, you could do that too. You could just sort of stream it up and
just append some kind of URL to it.
Yeah, you could do that too.
I know it's kind of breaking your architecture that you're talking about.
No, I think that's okay to add like a file upload to the WebSocket.
Like a put command almost over WebSockets.
Yeah, because if you go back over to this, I guess is it in my hub? My check command method is probably actually in serial. It does sort of break the model a bit, but that's all right. So
if it gets us out of the delay land, it might be worth it.
Yeah, maybe it's in my hub. Yeah, here's where it kind of processes the commands coming in. This check command. The funny thing is when you're interacting with the serial port JSON server, you're sending non-JSON strings as commands, but you're only receiving JSON back. That doesn't have to be that way. I just did it to keep things simple. It's the same way I'm doing the tiny G. I'm sending the G code commands not as JSON, but I'm expecting JSON back.
So if it has a list, it has a send, it has an upload.
Yeah, in fact, just to show you, God, my Alt tab's not working well with this Google Hangouts. If I close this and I reopen the console, right, the commands are list, and I'll get back the serial port list. So I sent that, and I got back this. But if I say stuff like open COM21, notice COM21 is not open. But now, oh, you got to do baud rate. So
Yeah. Hey, John, give me 1 second really quick. I got to check my kids really quick. 1 second.
Yep.
His kids?
There. John?
Yeah, I'm here.
Hey.
Okay.
Sorry about that.
That's cool. Yeah, so I was just showing you some of these serial port commands, but Here, I'll
Okay.
just finish
But
that
that's
one
going
up.
to Go handler, yeah.
Open COM21 baud rate, and then notice the checkbox auto checked. That's really all that's happening when you click around.
You open 2 ports?
Yeah, you can open up as many ports as you want in parallel.
Huh.
That's what I mean. You could do a mashup of multiple serial port streams in your browser then, which is what I'm going to do for that position sensor.
Ah.
That way, you know how you're talking about that Kinnan, where you're
Yeah.
sort of letting the tiny G be where the merge of the data stream goes? I'm taking a different approach and saying let the merge of the data stream be at the browser level.
As long as you can get past the timing issues.
That's always definitely a concern. And so, like, this top 23 is my oscilloscope. So, if I wanted to also have, like, a live oscilloscope view.
Oh, it is?
Yeah.
What oscope do you have that has a serial port?
It's just a USB oscilloscope. Those are getting pretty common because they're cheap. Yeah, you get a really good one for, like, 150 bucks.
That's cool.
That's got, like, you know, gigabytes worth of data processing available.
Wow, that's actually cool. Because I have like this Saley. We got in on the new logic analyzer build, so it's actually next month or something like that. It's supposed to be coming in, but it's all over USB, so you can actually just kind of like script that. That'd be kind of neat.
Yeah, exactly. I mean, I feel like that's a lot of real-time data, so doing the browser is tough, and usually they'll write a desktop app for it, but even those sometimes lag.
Yeah. But sometimes you want to be able to just, from like a logical analyzer's point of view, depending on the API of the thing, like if you wanted to send like a command, you could actually read the bytes off of the serial logic analyzer to make sure you're getting the same thing coming back, kind of thing.
Right. And again, that's why having the serial port server not be like new line centric, instead just send data as it gets it, would make sure it supports other things like an oscilloscope. You don't know if that data is
Well,
coming
see,
back to you.
like this is what the so let me see if I can bring this up real quick and show you.
Yeah, do you want to share your screen?
Yeah, I will in a minute. All right, check this out. You see this?
Yeah, the node serial port.
Yeah, so they have an example in here. Let's see. Now I'm gonna like make a liar out of myself. Yeah, so check this out. So maybe even like a constructor for that would be cool, right? Um, because like in the Go server you could do something like the equivalent of that.
Yeah, where you put it in whatever parse mode you want.
Right, right. So like the constructor itself is when you, like if you passed it a new line or a tab or whatever the hell you wanted,
Totally. So like,
it would do that.
right, when I was showing you that open command, instead of just
The
open com22 baud rate, you could also say like mode and maybe we gotta finally, I was gonna create like a JSON format instead, so you could say something like command, is open, and then you give extended parameters like mode, new line.
Or like parser new line, or
parser.
dilemma or whatever. Yeah.
And all you're just doing is you're just adding
Parser.
more logic and code base to the serial port server, and I think that makes sense. I mean, why hasn't somebody written a serial port WebSocket server a long time ago? I was surprised there wasn't one out there. I didn't want to write one from scratch because it's a pain.
Yeah. Yeah.
So I see that you're getting one here in Node. And Node could be a good way to go instead of doing it in Golang.
The only thing that I would say, which I would agree with that statement 120%, would be that you actually get the ability to, once you do that in Node, you get the ability to like break into thousands of other projects out there.
Okay, here's my problem though, and why I didn't go with Node, because I considered it as when you're doing low-level stuff like serial port, you're going to need code written in C in many cases, and that is the case for that Linux version and the Mac version, and Node is isolating you too much from the low-level stuff. So it's dangerous to think that Node's going to solve your problem, and then you get stuck, and you're like, oh crap, I don't know how to toggle on and off, flow control. And serial ports, there's just way too much code in C to control serial ports. There's not.
Well, see, so the Node module itself, like to be a response, not authoritative response, but it actually supports all the flow control stuff, and it's written in C. So it's actually building. You have to build it with what is it, Node GYMP or something like that, to actually get this to work.
Yeah.
It's all C++. So here's Windows, Unix, and so let's go to Unix.
Okay.
And see, so it is actually, we do have all of this C++ code that available to us. So I think it just basically just can compile it down. And so here we go. So we have our Exxon, and it has CTS, RTS. Actually, Rob, partner of ours in Synthetos, discovered some problems with this code and flow control because we were using it for something. We discovered that. And then the blanketing, like putting down like socket I/O, it was killing our performance in Node when we wrote a Node TinyG app, to the point like it was like doing these retransmissions and all kinds of craziness that like TCP/IP is already taken care of for you. So a generic Node WebSocket serial port does not exist. So this is only half the equation, right?
Huh.
To my knowledge. The WebSocket stuff, the socket I/O is just really, really heavy-handed. And when you're sending thousands and thousands of messages over WebSockets like we are, which is, you might not be doing for a database application, with some banking app or whatever, it really kills your performance.
So you're saying, I mean, this does feel like it's somewhat the serial port JSON server I wrote, but you're saying it did kind of not work well.
No, I'm saying this. So this is only part of it, though, right? This is not WebSockets at all. Yeah. This is your serial port, and the serial port, it actually there was problems with it. The guy's in Virginia, actually, Voodoo Tiki God, and so we've talked to him a couple of times, and he runs the Node.js RobotCon or something. I don't know the exact name, but no, this is a very good start. It's actually very good, and this works. It does. Well,
because I am thinking this might be a better way to go than to keep investing energy into a Golang server.
So the downsides, what are our downsides? We have single-threadedness, right?
You really don't have any threads in Node?
Well, you have a sink. I mean, have you seen a sink?
Because that is very worrisome. I have tons of threads running in Golang.
So you can do something like this, where this module would help. It helps quite a bit. You can kind of let's see.
Meaning somebody wrote threading probably in C and then hooked it into the JavaScript layer.
Right. So you can do this thing. The main primitives are like right here, like parallel, and then in series, and then you give it callbacks and whatever. So. But as far as like this is what it's the longest time had me like scratching my head trying to figure out how am I going to wrap, like I want to do this in Node. I've wanted to do this in Node for a while, but how do I take like this idea of sending a file and making it work with like the whole like sends a file, receives a response, parses the response, sends a line, receives a line, parses the line, updates our model, sends its WebSocket messages out, goes back and says, oh, I can send another line. And I think where we're at, and this is all theory, and this is kind of, I've actually been thinking very hard about it for a while, was like, you send a line, you get your response, you notice the QRs, and then in your line sender, you have a primitive to where you send how many lines that you want to send.
Yeah.
So you're still in a single-threaded application. But at that point, you kind of say, like, you send your first line, you say you have 24 left in the buffer after your first line, or 23 or whatever, in the response that comes back. Or actually, it might even be more accurately 24 because the time it sends it back, it was already done with the first line. Like, oh, okay, so I send 12 lines. And so you say, all right, send the next 12 lines that are in the buffer. And then I do that. And I don't worry about overflowing the serial buffer because, flow control's on. and then I go back and I read my responses, and then I start syncing off of that.
Yeah.
And so your send method is actually it takes parameters of how many lines to send, and maybe you have this like shared buffer to where you dump in your serial write buffer, and it could maybe you buffer the whole 200,000 line file, and all you're really doing is say send how many lines,
Yeah.
and then you also have another method that says send and then what bytes you want to send.
I think all of that is achievable. In fact, I don't even think it's that hard of a project because
Well,
all you're really
the
doing is
hard part has been like trying to come up with the architecture how you do it.
Yeah. And look, I think that I've got a great start with that serial port JSON server, and that you really could just play around with it, and after like a nice Saturday, Sunday, you actually could have stuff working, and you've invented your own little JSON parameters, and you've modified the widgets in ChiliPeppr to kind of take those instead, or you could do it in Node. I feel like going Node or Golang is almost maybe going to be about the same. The only thing is, I was also after a single compiled binary, so I didn't have to have people like, oh, I got to go download Node and install
and
it,
that's what I like
figure
about
it,
Node. You can actually do that.
you know. So I wanted just a single compiled binary.
Yeah, so that's the one of the other reasons I liked Node, because you could do this, because they have this Node. Let me show you this. So this guy Roger Wang makes this thing called Node WebKit, and let's see, how to package and distribute your apps. So in Windows, you do, or there's Linux, I'm sorry. In Windows, you do that right there.
Yeah.
And now your Node app is just an app.exe.
And then when you run it, does it have to open up WebKit?
No. Node WebKit is just the project name. I mean, it could just run a little standalone Node app.
That's just on the command line.
Right.
And is that a small enough one that it'll run on Raspberry Pi or BeagleBone?
Yeah, like the minimal what you're getting away was like 26 megs or 23 megs or something like that, the binary.
Yeah.
But I mean, it's definitely able to be run.
Yeah, which isn't bad. Although I'll say that the Golang binaries are like 7 or 8 meg, and that I've got.
You're embedding an interpreter. That's all.
Right, and what Golang does is it compiles to native, so to screaming fast. And with the notion of doing this on embedded chips and whatnot, that was another reason I went with Golang. I'm like, I'd rather have it be lighter weight than trying to do a full like JavaScript parser.
Right. I'm not saying I have the right answer. I'm just saying that this might work too.
I also get concerned about garbage collection, and JavaScript is garbage collected, and so is Golang. But I feel like Golang's garbage collection is just amazing.
Well, I think like most JavaScript is like compiled now, though, right? I mean, like in the web.
The V8 engine gets it as close to compiled as possible. Yeah, so it is impressive.
I mean, it's better than Java.
It's way better than Java because Java, the garbage collection can kill you when you're looking for more real-time operations.
Yeah, I'm already dying from that.
And I feel like Golang, you also can start controlling that tighter as well.
Right.
I still would prefer Golang over Node, is my feeling. But I do think there's more of a community around Node than Golang.
I'm not saying either one of them is the right or wrong answer, and I think both of them have quite a bit of stuff going for them. I think this is so. I mean, realistically, this is going to be pushed down to TinyG,
Right.
And then ChiliPeppr just handles.
Which, if you do, I feel like you either are going to be able to do Golang direct on your TinyG, or you're going to be able to mimic it easier than doing it in JavaScript. But
so the current idea is get like some kind of vanilla ARM chip, and get a CC2000, whatever it is, the wireless chip that everyone uses now. It's like this little embedded wireless chip.
Right, which also has its own OS on it, right?
Yeah. Well, actually, I don't know. I think they have drivers, but that's funny that you bring it up because it's supposed to be embedding a. I think the rumor right now is it's going to be embedding a Cortex ARM chip inside of that chip. So not only will you have all of the stack of like TCP/IP, Ethernet, and all that stuff handled for you, but you will actually have an embedded processor to be able to distribute this added gains from the stack itself. So the idea is if you did something like that and you pushed it onto TinyG, then and you had the ability, then you basically we still all like the JS fiddles.
Yeah.
So you have all your JS fiddles and everything like that, and then you could have maybe like some primitive from the embedded chip itself. It's like, go grab this namespace. It grabs this namespace and runs on the embedded. And so at that point, the chip is serving you the embedded stuff, and then it's doing all the rest of it. Like it's got the memory to be able to parse or upload a big file and run it from there, and then just send you JSON messages over the web or over the network web, whatever. And all you're doing is doing like control aspects from that part, like send, stop, pause, that kind of thing. That's gonna be cool. But yeah. So, anyways, I'm saying I think there's probably a couple valid platforms. The embedded being one of them.
Yeah, and I feel like with all of that, depending on which direction it goes, because none of us can really predict, as long as there's sort of these cool UI elements in a browser, you're always going to benefit for whatever happens down at the hardware and the protocols to talk to it. So I think it's great, no matter what direction it goes.
Right.
And
okay, so I think I've got a couple notes here to go ahead and take a look at and see if we can't figure something out. Would like to kind of hash out, maybe we can do some independent research between the two of us over the Go server and the Node.js server. I don't know which one would be more simplistic. I don't want to do feature creep, or not feature creep. I know that you have some external stuff that I might not have on my radar, and I don't want to blow over that, but I don't want to be constrained by it either. So I want to figure out how the best way to go about satisfying them both. Because the last thing I want is us to start duplicating work to get ChiliPeppr working. That seems like a really bad idea. So,
well, I may play around with some of the Node stuff and sort of see if I'm happy with it. I tend towards, if I had to just make a decision right now, I would tend towards just sticking with Go. But that's just my preference. But that's also based on the fact that I haven't done a lot of Node stuff, even though I love JavaScript. I think JavaScript is an amazing language. I think a lot of people poo-poo how badass JavaScript is.
Right. No, I'm with you too. I like the idea of having the binary, but I like the idea of having a binary that wraps up all of it all in one too. And Node would actually give you that. Like if you wanted to write a 30-second Chrome or Node app that I can make an exe and distribute to everyone, Node would allow you to do that, where Go kind of wouldn't, right?
Right.
That would be my only That's my only idea where I think that Node, but performance though. It all comes back to performance. Like if you're right about this, we want to play that. And then the other thing I wanted to take a look at, if you could probably do another screen share, would be dude, I'm going to send you a BeagleBone too. I've got an extra one here.
I'd love to get one and play with it because I checked it out more after you're talking about it, and it does look really sweet.
Yeah, it's kind of ridiculous, and especially since they just switched to Debian. So now they're not distributing Angstrom, and the Debian stuff comes with Cloud 9 on it already, so it already has Node.js on it and everything.
That is cool.
Yeah, so anyways, give me your address. I'll send you one of my extra ones I have here. But no, let's talk about the jog really quick. If you had a second for jog.
For job?
Jogging.
Oh, the jogging, yeah, for sure.
Yeah, see how you're doing that real quick.
So let me share my screen.
I see your screen right now.
Oh, you do? Okay.
Yeah.
Did I just turn it off?
Yeah, you did.
Okay. Okay, so on the jogging, what I find is that as long as I'm holding down Control and Shift, I've got pretty good jogging. Here.
Mine goes maybe half an inch and stops.
I think the problem is you're on a Mac, and so your Control Shift wasn't working.
All right, so this is a we should figure that out because when I push down, even just holding right arrow, it only goes about half an inch and then it just stops moving. Is that what's supposed to be doing?
I'll show you. See if you just do the right or left arrow, you're moving 0.001 millimeters.
But it doesn't continue to move. It moves that.
Yeah. It'll continue to send it, but only every 200 milliseconds. So you're going to only move 0.005 millimeters in 1 second. So Control Shift is working way better for me to get it into this fast mode. Because that's not working with those accelerator keys.
Well, I'm on another machine too with different settings, so I think I'm bringing to life like a jogging deficiency here. Because
So,
my movements are on a lead screw on the other machine.
yeah.
And so that's what it is. Okay.
Let's do this. You've got it running over on your computer, and you've got it hooked up, because we could change this right now. And you could hit reload and just see if you're happier.
Hold on, let me hook up my BeagleBone to this one so I've got my little sender here. Of course, I cleaned my office and I can't find anything. Oh, here we go. Need to load up here, John. Give me a second.
Okay. So what I'm going to do is I'm going to just make the arrows be 1 millimeter without any accelerator keys. Now, the danger is don't do any of the accelerators, because you're going to end up going 10,000 millimeters and go off the edge. Although you probably have limit switches and I don't, so it's always dangerous.
Yeah.
So I'm updating the widget, I reset the base, and now when you reload, it's going to jog. When you hit the left arrow or right arrow or any arrow key just once, it's going to jog at 1 millimeter. Okay, so, well, here, I'm just going to use the arrow keys. So, let's make sure that worked.
39. I'm starting the server now.
No, it didn't take it.
Okay. Scan. Good to go. Found it.
No. That must be.
All right. Cool.
Hold on, I didn't get the right piece of code.
No, I mean I've got mine, all my stuff up now, and it's working.
Oh, sure. Okay.
I mean, it's so cool being able to like just connect this machine. I've got a touchscreen BeagleBone, black, that I can actually just like start it up and then turn on the JSON sender, and then I can actually load up locally.
Yeah.
Yeah, it's really cool. So I can load up ChiliPeppr inside of the same machine that's sending it.
That's sweet. Okay, so we're going to say. I'm going to change the base val. Okay. That should work. Cool. Okay, so I got that going. Now if I hold down Shift. Yep, okay, so update, set as base. Okay, if you reload TinyG now, you should get
Alright, give me 1 second.
much quicker jogging.
Let's see.
Yep, there you go. So just don't do any accelerator keys. And
Yeah,
just,
well, I just did Control R on the Hangouts because I saw your screen, thought it was mine.
no, that's hilarious.
Yeah, it was like, oh no, I just did that, didn't I? All right, so let's see. Yeah. Can you see my screen now?
Let me see. I do think that your technique is your technique of sending a long command and then sending the exclamation point is better. It scares me a little bit because I really did run into problems with that in TGFX where it would run to the edge of my...
So how do I? All right, so if I just, what are these buttons? What do the buttons do?
So they're just, go ahead and they just jog. I mean, go ahead and try them. Just hit them, hit it once and you should get it moving 1 millimeter.
All
There you
right, so
go.
you got, so it's on mouse release, right?
So only when it's blue is it in jog mode.
Well, I've
Just
clicked
click.
right now, but
Yeah,
it's
all
not
I'm
moving.
saying with where the keyboard could arrow keys work.
What,
Otherwise,
where do you mean? Where is it blue? You mean right
so
here?
just hit the jog button.
Oh, this.
Yeah.
Ah, okay. All right.
Now you're in jog mode.
Okay.
So only when it's blue. That way it's not dangerous. I will say in TGFX it was hard to get it into jog mode and then sometimes
Yeah.
it stayed in it and I forgot it and I'd screw
All
stuff.
right, so that's much faster. Oh, but I'm just like slamming.
Right? See, it overdoes it though.
Right. That's why I'm saying I think it's better to go the other way, is where you hold it down, you give it the max, and then when the signal comes up, it sends it stop reset.
Yeah. Yeah.
Yeah, see,
I didn't
yeah.
think about doing that until you mentioned it because that just doesn't feel like that would work on stuff like Gerbil or the Gerbil shield.
Oh, I mean, if you're trying to do that compatibility, I think a lot of the stuff wouldn't work.
That's why I kind of took more of a generic approach initially, but I don't mind making changes to make it way cooler and slicker for the Tiny G.
Yeah, it seems to be working much better now.
Yeah, that's
I
why
mean,
I've been just doing Control Shift to achieve what you're now seeing right now.
What do the home buttons do?
Okay, so the home button, that one is not linked up yet, but it would put you into the homing mode, the G28.3 or whatever.
Yeah. Okay.
Or G28.2, I forget what the homing one is. The 01 does the G28.3, but you can also do that per axis, by the way, if you do that little pull-down menu on the X,
But
Y,
what if
or
I want to
Z.
set that to 0?
For what? For each axis or for all of
No,
them?
where my position's at right now, that's 0.
So that position is read from the feedback from the Tiny G.
Yeah, I have this idea of, or the way TGFX works is I can right-click here, like, or obviously you should have another button that does the same thing, but I can right-click on anywhere of my build volume platform,
Yeah.
and say set position here, and it will basically set it as 0, all axes 0 to this spot right here.
Yeah.
It's kind of like a poor man's homing because I am doing a
Well, if you
28.3.
hit the 0 button right now on the axes widget,
It
it'll
moves
do
it
what you
back.
just said.
No, it moved
But
it back down here.
yeah, okay, I get what
Yeah.
you're saying.
Yeah, but it's not. This is not a big deal. I'm just telling you that this is the way I've actually had it working. And
Actually, what command did it send when you hit 0? Yeah, it did the G28.3.
it did. Yeah, yeah, but it took so it didn't take the offset to where you were at.
Right. So
So
you're basically putting it into like a work coordinate.
so let's say it's like it's like there. Okay, so 2 by 2.
Yeah.
So what you could do is can I send commands here?
Yeah, absolutely.
2 dot 3 and then x0 y0. Huh. It's moving it back.
Well, remember the 3D viewer knows what 000 is.
Oh, wait a
So
minute. Hold on. Let's do this again.
it feels like you're trying to make, I don't know.
x2, y2. There you go. That's what I expected to do. And then 0, but it's not. So it's basically saying like
Your G code would have to change. That
no
origin
no
G
no no.
code
You're
is at
setting
00.
offsets. It's going to set offsets inside of the model itself of tiny g.
Right. So this is an area where I did not put a lot of energy yet. Is like that whole work coordinate
Yeah,
system.
that's okay. Hey,
Um,
let me give you a call back, or we can do this in a minute. My wife just walked in, and we've got she's going to take him to the pool for his dive meet, but I'm going to be
yeah.
here, and so we
Yeah.
can
Let's
talk.
take a break because I gotta go grab some lunch.
Yeah, yeah. Just give me a call back, and let's talk a little bit more. I would like to kind of like hash this out. I'm going to be here this afternoon to be able to start looking at some of this stuff.
Okay. Cool.
All right,
All
man.
right.
Yeah.
Talk to you later.
So, if anyone else has questions, would like to see this video offline, please let John and myself know, and we'll go from there. Thanks.
Okay. Bye.
All right, man. Bye. How do you save it? You know how?
It auto saves.
Ah, sweet. All right, later. Hey, man.